Hello. This morning I want to talk about a mixing problem. So there's a lot of different ways to set these up, and just many actually. But this is a pretty basic example. I want to solve it in two different ways. And the things about the setup here that would make this particular problem different from another mixing problem could be I don't have any I don't have any change in volume, first of all. I don't have anything going since there's no change in volume, that actually gives a lot of constraints. So the flow between the two has to be the same because there's also no flow in and no flow out of either of them, other than going back and forth between the two tanks. So what we would actually be solving for here is, let's say there's a certain amount of something that's mixed into these tanks. We usually just go with salt. Say maybe it's grams of salt, and there's some starting quantity of salt in this one, some starting quantity of salt in this one, and what you're really finding is the relationship of the change in salt between the two tanks over time, given that in this case the flow going in both directions is the same, but one has double the volume of the other, which isn't apparent in my picture, but that's how it should be. Um, yeah, so that's the basic problem. And so we're going to solve this two different ways. So basically, we have the rate of change with respect to time, and any of these types of problems like this is equal to the rate in times the concentration in minus the rate out times the concentration out. And the key thing here, you can add as many of these terms as you need for everything that's changing. The key thing is that the rate in times the quantity in, those should be positive values, and the rate out times the concentration out should be negative values. That's the key there. So for this one, we have two tanks. We're going to be dealing with a system of differential equations. The rate of change of the quantity in A with respect to time equals, so we need the rate into A, so that's this right here, 2 liters per minute. I'm going to leave off the units, but if I were to write them, you'd see they cancel, times the concentration in, which the concentration in the tank A is the current concentration in tank B that changes over time. So it's the quantity in B as a function of time divided by the volume in B, which is 20, minus, we're still dealing with A, so we want the rate out of A. That's this one right here, 2 liters per minute. The quantity in A, and this would be grams, per the volume in A, which would be liters. And had I wrote the units, you would see that this is liters per minute, this is grams per liter. What you end up with is grams per minute when they cancel. So rate of change, quantity in B with respect to time equals 2. This is the in going into B. It's coming from A. So quantity in A is a function of time per 10 liters minus 2 times the quantity in B per 20 liters. Okay, so this is the setup for the problem. This is how you get from the story to the mathematical setup, the equations. Now what we have here is a system of differential equations, and we're going to solve those. And you'll see, if I were to move everything to one side, we have a first order constant coefficient homogeneous differential equation. So I'll start the solution. Well, yeah, I'll start solving over here. The first thing I want to do for the first method that I'm going to use to solve it, I want to rewrite these terms. So just because it's going to make it simpler for me algebraically, I want to rewrite this so that q of a is going to equal x, and it's technically x of t, but most of the time I'll just write x, and q of b equals y of t. Obviously you don't have to do this, but because I'm used to working in x's and y's, it's gonna just make it simpler. I'm less likely to make a mistake this way. So we have the derivative of x equals 2 over 20 is 1 over 10. QB is y minus, we'll just keep this as a 10, 2 over 10 x. Then we have y prime equals 1 over, no, let's keep this as 2 over 10. 2 over 10 x minus 1 over 10 y. And those came from right here. Now I just want to order things so that the x and the y are, so that they're lined up. And I'll go ahead and actually set it equal to 0. So we have x prime. When I move this term to the other side, I'm going to get plus 2 over 10x minus 1 over 10y equals 0. So now it's more apparent that this is first order homogeneous constant coefficients. We have y prime. Actually, hold on. Let's try to keep them beside each other. So this is going to be negative 2 over 10x. Y prime and plus 1 over 10y equals 0. Now we want to cancel things, which we can do that now, but before we do that, actually we can't do that now. Let's pull out, there's this little trick. So for these two terms right here, we're going to say this is equivalent to big D plus 2 over 10 times x. So we factored an x out of this, and we changed this into big D, which is going to stand for like derivative of m minus 1 over 10 y equals 0. Now for down here, nothing to factor out of the x term. Is something to factor out of the y term. Equals 0. And we're going to, it doesn't matter which one we cancel. Let's just cancel out the, let's cancel out the y's. So we're going to multiply top and bottom by, well, not by the same thing. We're going to multiply the top by d plus 1 over 10 and the bottom by positive 1 over 10, so that way they have the opposite sign. So multiplying the top here, we're going to get d plus 1 over 10 times d plus 2 over 10 times x minus 1 over 10 y, oops, let's not put the y yet, times d plus 1 over 10 y equals 0. On the bottom, we're going to multiply by 1 over 10. So this will be 2 over 100 negative 2 over 100x plus 1 over 10 d plus 1 over 10 y equals 0. Now we're going to add these two equations together, and when we do, we see that negative 1 over 10 d plus 1 over 10 times y and a positive 1 over 10 d plus 1 over 10 times y, those two terms cancel. So we're going to be left with these two, this times this times this, plus this times this. That's what we're going to be left with. So I'm going to go ahead and multiply these two. I'm going to go ahead and distribute this right here. So we'll have d squared plus 2 over 100 plus, we're going to end up with 2 over 10d plus 1 over 10d, which will be 3 over 10d. 3 over 10d times x minus 2 over 100 x equals 0. Now we're going to distribute the x back in, and when we do that, the x times d is the derivative of x. X times d squared is the second derivative of x. So what we're going to end up with is the second derivative of x plus 2 over 10x minus, plus 2 over 100x minus 2 over 100x. Those two terms cancel. And then plus 3 over 10x prime I like to write the plus 0 x here equals 0. So now we're going to take this is our this is in a more familiar format now. Now this is something that we kind of know how to solve. I think that if you already know how to solve a differential equation, you would already know how to solve this type. This is a relatively simple type of differential equation to solve. So we solve this by changing the x's to r's. It's just convention. R squared plus 3 over 10r equals 0. So what we're actually wanting to solve is we'll solve this to find r. So this is going to be r times r plus 3 over 10 times r equals, oops, I wrote too many r's. R times r plus 3 over 10 equals 0. So we can see from this that r equals 0 or r equals negative 3 over 10. And these are going to go into, let's actually write this down here. So what we just found is x of t. This is our first solution. X of t equals c1 e to the 0 t. So this is where the r's go. Plus c2 e to the negative 3 over 10t. And I can't delete that very easily, so let me just write it above it. So this, obviously this goes to 1. So what we have is x of t equals c1 plus c2 e to the negative 3 over 10t. So now this is our solution for the function of x, which x, as I had said, I made that tank A. So this is how the quantity of salt, or whatever you wanted it to be, we'll say it's salt. This is how the quantity of salt in tank A will change over time from the quantity of salt in tank B. And then, of course, if we plugged in these, if we had some initial conditions about what our starting values of salt were, we could solve for C1 and C2 and have a more full equation. Now, to finish solving we can solve for y of t. There's different ways you can do it. One way is you can recomplete the whole process but cause the x's to cancel. The other way, and I'll do it this way just to show that there's another way to do it, is to take our solution for x and plug it into one of the equations. So just get rid of all of this. All right, so let's take, this one has 2 x's and 1 y. Actually, I don't need this other equation right now either. We're not going to use this one. So let's take this and put it as x prime plus 2 over 10x equals 1 over 10y. I just wanted to rewrite it in that format because what we're going to do is we're going to solve for x's here. So if this is x of t goes in right here. The derivative of x of t goes in right here. So let's take the derivative of that. The derivative of a constant is 0, so we're left with the derivative of this term. The derivative of this term is just negative 3 over 10 c2 e to the negative 3 over 10 t. It should be right, yeah. Plus 2 over 10 times c1 plus c2 e to the negative 3 over 10 t equals 1 over 10 y. So we can distribute this, and we can also take this and multiply it by to this side here, and that will be our solution for y of t. So I'm going to write y of t on the left hand side because that's usually how we like to write it. Y of t equals, so take 10 and multiply it by both of these terms. So first we're going to have negative 3 c2 e to the negative 3 over 10 t. Then when we do this, we just multiply by this and we get 2. So we're going to take 2 and distribute it into both of these terms. Plus 2 c1 plus 2 c2 e to the negative 3 over 10 t. Yeah. And now we can combine these two c2 values because it's a number times c2 times e to the negative 3 over 10t. And this one's the same, a number times c2 times e to the negative 3 over 10t. So we can combine those to get negative c2, and I'll actually go ahead and write that down here. So we left with 2c1, and then minus c2 e to the negative 3 over 10t. So this is our solution. Now let's solve the same problem starting more or less from the beginning, well, from the beginning basically, but we're going to use a completely different method, which is nice anyway. I like having 2 different methods to solve a problem to check my answer. So we're not going to use x's and y's this time until the very end. And let's go ahead and use a different color here. Let's use orange. And drink some coffee. Okay, so now we're going to use linear algebra to solve this system of differential equations. So let's just rewrite them. But this time I'm just going to use the q's and b's just because I'm more comfortable using the q's and b's on this part. Except where I switch things, it'll just be kind of random almost. I think that's how you're supposed to write it. So the derivative of x, the form that we're putting is So this is a matrix, and then I guess I'll just kind of write this and then delete it. A times x, where this is a matrix and this would be a vector. And that's all we need because there's nothing else added to it. So this is the form we're changing it into. So for A, actually hold on, let me do that in 1 second. Let me rewrite this first. I'll write it down here. Let's get the terms in order. It makes it a little easier to not make mistakes, and I'll do the same kind of canceling. So we're going to end up with the derivative of, so the rate of change of the quantity in A with respect to time equals negative 2 over 10 QA plus 1 over 10 QB, the rate of change of the quantity in B with respect to time equals 2 over 10 QA minus 1 over 10 QB. Now let's turn this into a matrix. So we're going to have negative 2 over, oops, that's definitely not going to fit in that little box. So let's make our box bigger here. So we have negative 2 over 10. We have 2 over 10. These are coming from top left, top right, bottom left, bottom right. 1 over 10 and negative 1 over 10. And this is multiplied by QA over QB. And the reason for that is because if we were to take this top and multiply it by this, it would be negative 2 over 10 times QA plus 1 over 10 times QB, which is what we have for the top equation here. Now what we're going to do is we're going to use this little formula, the determinant of A minus lambda times I, the identity matrix, equals 0. And we're going to use this to solve for our eigenvalues. And so A here is equal to this matrix. Lambda times I is just lambda 0, 0, lambda. So what we're going to end up doing is we're going to take the top left term and subtract lambda, and the bottom right term and subtract lambda. And then we're going to find the determinant of that. So that's what we're doing here from this formula. So when we do that, so this minus lambda times this minus lambda minus this times this. That's what this formula means, and we set all that equal to 0. So I'm just going to do that all in one step here. Negative 2 over 10 minus lambda times negative 1 over 10 minus lambda minus 2 over 100. 2 over 100. And we set it equal to 0. Now what we do is we solve this for our lambdas, and our lambdas are our eigenvalues. And in our final result, the lambdas go in the same spot here that the r's went in. So this is going to be lambda squared plus 2 over 100. And then this is plus 1 over 10. Right, this way, plus 1 over 10 plus 2 over 10. So this is plus 3 over 10. Lambda minus 2 over 100 equals 0. Minus 2 over 100 and plus 2 over 100 cancel. And we can factor out a lambda. So we have lambda times lambda plus 3 over 10 equals 0. And we see from this that lambda equals 0. You know, I think I messed up somewhere. Yep. because now I have 3 over 10. No, when I subtract to the other side. Okay, negative 3 over 10. So this would be lambda plus 3 over 10 equals 0. Lambda equals negative 3 over 10. So you'll see that 0 and negative 3 over 10, that's the same solutions we got the first time for R. Now these are called our eigenvalues. They're not called eigenvalues over here because that's a different method. This method's going to use eigenvalues and eigenvectors. And oops, I guess I'll just keep the numbers. Let's put this somewhere else for reference. Okay, those are eigenvalues. Now, let me just delete this part here, I think. So now we have to solve two things, one for each eigenvalue. So for starters, let's start with lambda equals 0. And we're going to say the formula that we're using now, I guess I could have wrote that above. So this was our first formula. I kept it because they're very similar and I wanted that to be noticeable. So now we're going to use, instead of the determinant of a minus lambda I, we're going to say a minus lambda I times k, which I guess this is a vector. I think it should have vector over it. I'm not sure. Equals 0. We're going to use this formula. So the a minus lambda I, we already found that earlier. That's just, well, I sort of found it. I found it, but I didn't actually write it out. So negative 2 over 10 minus lambda 2 over 10, 1 over 10, negative 1 over 10, and our k is a vector, and we just write k1, k2, and then equals 0. You could just write a 0, or you can write it as a vector. It is a vector. So 0, like that. And for this one, if you multiply this out, you'll have two equations, but we only need one equation because by some strange math magic, the two equations should always give you like basically the same answer. It doesn't matter which one you choose. So I'll just choose the top one. Sorry, I need to plug in lambda. So this is negative 2 over 10 minus lambda, where lambda is 0. And this was also supposed to have a minus lambda, so this would have been minus 0. So I can actually ignore that because since lambda is 0. So now we're going to multiply the top. So we have negative 2 over 10 k1 plus 1 over 10 k2 equals 0. And now all we do is we sort of solve for k1 and k2, but you'll notice that you can't actually solve this equation because there are two unknowns. So you're not looking for a solution, you're looking for a ratio between k1 and k2. The easiest way to do that will be to get one of the k1 or k2. It's easiest usually just to get it by itself and then set the other one equal to 1. I'll show you what I mean. So let's add 2 over 10 times k1. Let's add that to both sides. So we get 1 over 10 k2 equals 2 over 10 k1. Then we're going to multiply both sides by 10. We have k2 equals 2 k1. Now if we set k1 equal to 1, I'm going to kind of save this information up here. So when we have lambda equals 0, that's our eigenvalue. Our eigenvector is going to be, let's try plugging in a 1 for k1. When we plug in a 1 for k1, we get a 2 for k2. Because if this is, so when we plug in 1 here, we get 1 times 2, which is 2. k2 equals 2 is what we're left with. This is our eigenvector. this is the eigenvector that goes with this eigenvalue. And what this is telling us actually is that this right here, so when lambda equals 0 for this eigenvalue, the ratio between the top and the bottom equation needs to be a 1 to 2 ratio for the value that's multiplied by the term that has lambda equals 0. And you can actually see already down here that that's true. So if this first term here and this first term here is where lambda equals 0, and we see that the ratio between our constants is a 1 to 2 ratio. They happen to also be a 1 and a 2 here, but the difference is the first method that I solved, you just get two numbers and you don't really see that there's actually many solutions. When you use this method that I just used, you know that you can plug in any value you want for k1 and k2. It's the ratio between these c1 and c2 values. It's the ratio between them that matters. All right, so let's do the other eigenvalue. And so this is lambda equals -3/10. Now this time I need to remember to subtract. So we have -2/10 minus -3/10 is going to be a +1/10. The bottom number I'm actually not worried about because I'm just not going to use it. Then on the other side here, this is just 1/10. And once again, I'm not worried about this number because I'm not going to use it. Equals k1, k2. Oh, sorry, not equals. Oops. Times k1 over k2. k1, k2 equals 0/0. Now, same deal. We're going to end up with 1/10 k1 plus 1/10 k2 equals 0. Let's subtract the k2. 1/10 k1 equals -1/10 k2. Multiply 10 both sides by 10. k1 equals -k2. Oops, not divided by anything. k2. So let's try plugging in a 1 for k2. Let's write that up here. So we have lambda equals -3/10. That's our eigenvalue, and our associated eigenvector is going to be, let's plug in a 1 for k2, and we get a -1 for k1. This is our eigenvector. And now you'll notice just by chance, the numbers that I chose here, I have a 1 associated with the bottom and a -1 associated with the top. In the solution I got the first time, I have a +1 associated with the top, a -1 associated with the bottom. And doing it this linear algebra way, you see that it doesn't matter as long as they're opposite in sign. So this ratio is telling us that they're the same numeric value, same magnitude, but opposite in sign. And that's what we have. The first way, we ended up with just one way of solving it, like one specific one. I'll say that better, like one precise solution. They're both precise. I can't think of the right word I want. We only see one of the possible ways that you could solutions that you could end up with. When we solve the linear algebra way, you see that there's other possible solutions, but you see that the one that we had the first time is valid. Okay, hopefully that made sense. So now if I rewrite this out the way that it is, first I'll rewrite it in the middle here, then I'll rewrite it off to the side, because I'll go ahead and plug in some numbers afterwards. So our solution then is x of t equals c1 times our first eigenvector, which is 1 over 2, times e to our first eigenvalue, which is 0, times t, plus c2, times our second eigenvector, which is negative 1 over 1, e to the negative 3 for 10t. So this is the solution, but if we want to rewrite this in this format right here that we're more familiar with, we can, you just multiply through. So when you multiply everything by the top, in the top, like the top row is going to be x of t, the bottom row is going to be y of t. Or if I stuck with my original notation, the top row will be q of a, the bottom row will be q of b. I guess I'll write it that way over here. So we have q of a equals c1 times 1 is c1. E to the 0t is just 1. So this is c1. And then negative 1 times c2 is negative c2. E to the negative 3 over 10t. Q of b, doing the same thing. We get 2c1 plus c2 e to the negative 3 over 10t. So both of these are solutions to our equation where I have x of t equals q of a, or not q of a, qa of t, y of t equals qb of t. Those are equivalent. So these are both answers to our system of differential equations solved using two different methods. I think I'll try to plug in some values. I didn't actually test this part, but I believe both should give me the same number. So let's just see what happens when we plug in two numbers there. And I'll go ahead and use another different color. Let's use blue. All right, so let's get some starting conditions. Let's say that this one starts with, how about, what's going to cancel out really nicely? I don't know. How about just 4 grams of salt? And this one starts with 1 gram of salt. Really tiny amounts. Yeah, let's just do that. Let's see what happens over time. So if we take this first set of equations here, we're going to have, is that going to give me what I need? Q of A. Yeah, so if this is a starting condition, this is at time 0. So at t equals 0, we're going to have QA, which is the quantity in A, is 4 grams. So we're going to have 4 equals C1 minus C2 times e to the negative 3 over t times 0, because we're at 0t. QB is going to be 1. That's the starting quantity in B, equals 2C1 plus C2. If we solve this set of equations, we can just add it as it is, and these are going to cancel already. So we're going to get 5 equals 3C1. 5 over 3 equals C1. And so that's C1. Let's find C2. I don't know, let's just use this one. 1 equals 2 times C1, 10 over 3, plus C2. This is the same as 3 over 3. We're going to subtract 10 over 3. C2, so negative 7 over 3 equals C2. So now, I'll just write these above it. I'll just write it beside it. So C1 equals 5 over 3 C2. No, I'm going to want to write out the whole equation, I think. So we use this first method here, so I'll write it down here, and I'll keep the Q of A and Q of B so I think it's a little clearer. Q of A equals C1 is 5 over 3. And then this is minus C2, but this is negative 7 over 3, so we're going to have plus 7 over 3. 3 e to the negative 3 over 10t. And for the bottom one, Q of B equals 2 times C1, it's going to be 10 over 3. Plus C2, so minus 7 over 3. E to the negative 3 over 10t. So these are the equations. And if you graph these, you'll learn some information about what happens to the rates of salt over time. Now let's do the same thing, but with the other two equations. So once again, so x of 0 equals 4 grams. 4 equals C1 plus C2, because again, we're going to plug in 0 for t, so all of this goes to a 1. And then on the bottom, we have 1 equals 2C1 minus C2. These cancel just by adding them. Works out nicely again. So those cancel. We're going to be 5 equals 3C1. Divide by 3. 5 over 3 equals C1. Now for C2, let's plug into the top one this time. 4 equals 5 over 3 plus C2. Let's subtract. So we're going to end up with this, we're going to want to be, it would be 4 over 4, but we're going to want it to be, sorry, not 4 over 4, 4 over 1. I'll go ahead and rewrite it. 4 over 1 minus 5 over 3 equals C2. Times 3, 12 over 3 minus 5 over 3 equals C2. 12 minus 5 is 7. 7 over 3 equals C2. Now, when we rewrite these in for this set here, we have x of t equals C1 is 5 over 3 plus, and there is a plus because this was positive this time, so this is 7 over 3 e to the negative 3 over 10t. Y of t equals 2 times C1, that's going to give us 10 over 3. Minus C2, so minus 7 over 3 e to the negative 3 over 10t. Now, so I wanted to add some numbers because in these steps it kind of looks like these are two different equations, but you'll see that actually they're not, because when you solve for C1 and C2, even though you can end up with different constants for your eigenvectors, you'll still end up with the same values for C1 and C2 when you plug in your initial conditions. And that's all. Thank you.